Cramer, ACT Prep number 2, nuclear power. Alright, another area of weakness that we have seen on the ACT MME Prep would be for chemistry is nuclear power. So as a quick review, remember nuclear power, we're talking about the atom here, and atoms can be changed. And at the top of your paper we have, remember Democritus, he thought that atoms were those small little hard balls. And then in the early 20th century, scientists learned that no, there are lots of different parts to the atom and we can actually split them and fuse them together in both fusion and fission. But not all atoms are stable. Neutrons in our nucleus, and if you remember from our earliest physical science, in the center of the atom we have protons and neutrons. Neutrons add a strong nuclear force without repelling the protons. Protons have a positive charge, neutrons have a neutral charge, so they don't repel. So when an atom adds more protons, as we move down the periodic table, they have to add more neutrons, kind of like glue, keeping the whole nucleus together. Eventually, there is a very strong nuclear force with those neutrons, but it's not strong enough. And that's when we start to have a radioactive decay, and that's what it talks about in that second section. The strong nuclear force is a short, distant force. The electromagnetic repulsion of the protons is a long distance force. So here they're talking about how protons are repelled from electrons, and the nuclear force between protons and neutrons is really short, but protons and electrons much further apart. Eventually, if you get too many protons, and the repulsion of the protons then wins over. So anything over 83 protons inside the nucleus is going to undergo what we call radioactive decay. And there are 3 types of radiation leading to that decay. We have alpha decay, beta decay, and gamma decay. And the chart summarizes some of this information for us. Alpha decay is our low energy particles. It is a helium nucleus. So helium, which is He on the periodic table, has 2 protons and 2 neutrons, has a mass number of 4. And alpha decay, those helium particles are given off. These particles can be stopped by paper or by skin. The changes in the atom is that the mass number will decrease by 4 because it's losing 2 protons and losing 2 neutrons. The atomic number is going to decrease by 2 because it's losing the 2 protons. And remember that atomic number is the number of protons, mass number is protons plus neutrons. So as an example, if I have uranium-238, it's going to lose 2 protons. So our atomic number is going to change to 234. That changes our element to thorium. It's also changing the mass number as well, where it's losing 4. And it's giving off this alpha particle here. Beta decay, the neutron splits into a proton and an electron. This is going to need something a little bit more to stop this kind of a radioactive decay. This type of radiation is only going to be stopped by clothing or wood. Changes to the atom here. The mass number has no change in it, no change whatsoever. But the atomic number is going to increase by 1. So for example, if I have carbon-14, the atomic number increases by 1, which changes carbon, 7, to nitrogen, which has the atomic number of 8. The mass number 14 stays exactly the same, and it's the beta particle that is emitted. Third type of radiation is gamma radiation. This is the highest energy radiation. It can only be stopped by lead or many feet of concrete and is extremely dangerous to living things. There is no change in the atom at this point. The rays that are given off are considered gamma rays. So for us to practice at the bottom and the types of problems that you may see on the ACT, example would be, if fluorine 20 undergoes beta decay, what will it become? So in this particular case,